This is a Regents review of factoring. For question 1, you'll notice we're given a trinomial with an a term of 1. When we have an a term of 1, we need to think only about two numbers that multiply to make the c term and add or combine to make the b term. So in this case, we're looking for numbers that multiply to negative 24. So factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 6 and 4. If we look at the b term in this case, we know that these numbers have to combine to be positive. So that means the bigger number right over here must be positive. So if we make all of our numbers negative, we'll see the two numbers that combine to make positive 5 are negative 3 and positive 8. When the a term is 1, those two numbers go inside of parentheses with an x to make the factors. But as a refresher, we could also get that answer by using grouping. In grouping, we take the middle term and we split it into its two parts. So we know that positive 5x comes from negative 3x and plus 8x. If we copy down the other terms, we now have 4 terms, which we can examine in the first two terms, looking for the greatest common factor. Greatest common factor of x squared and 3x is x, leaving behind x minus 3. Greatest common factor of the second terms is 8, and that leaves behind that same factor of x minus 3. Once we do that, we can examine the numbers on the outside to come up with one factor, and the numbers inside the parentheses are the same, and that's our other factor. So we'll see either way we get the correct final answer. For question number 2, we'll use the same process. So we'll first examine our a, b, and c values. In this case, the a term is bigger than 1. So we want to ask ourselves, is there a GCF? Looking at 4, negative 3, and negative 27, there's not a GCF. So when there's no GCF and the a term is bigger than 1, we have to multiply it by the c term to find the number that we're multiplying to make. In this case, that number is negative 108. So we need two numbers that multiply to negative 108 and add or combine to negative 3. You can write out a list of all the factors of negative 108. 1 and 108, 2 and 54, and so on. But a faster way is to use your calculator, go to y equals, and put in negative 108 divided by x. After you do that, click second, and then graph, which is the same as table. And inside of the table, you'll see a list of all of the factors of 108. If you go ahead and do that now, you'll then need to only look for which two numbers are 3 apart, because we need them to combine to make negative 3. When I do that, the numbers that I see that are 3 apart, that combine to negative 3, are negative 12 and positive 9. So either way, whether you use the factoring method over here, writing out all the factors, or if you use the graphing calculator method, once we figure out those two factors that multiply to negative 108 and add to negative 3 are negative 12 and positive 9, we can split our middle term into negative 12x and positive 9x. From there, we can then examine the first terms here to find a common factor of 4x, leaving behind x minus 3. Examining the second factors, we'll end up with plus 9, leaving behind x minus 3. Further examining the numbers outside the parentheses, we end up with 4x plus 9 as one factor, and x minus 3 as the other factor. For expression number 3, you'll notice that we have two terms. When there are two terms, we want to ask ourselves whether we're missing the b term or missing the c term. In this case, there is no b term. When there's no b term, the second question we want to ask ourselves is it perfect squares? In this case, it is perfect squares. W squared is a perfect square of w to the fourth. So we know in the answer we would have w squared times w squared to get to w to the fourth. The second number, negative 36, is also a perfect square. So if there's no b term and both are perfect squares, we can write them as a difference of perfect squares, w squared plus 6 and w squared minus 6. Another way you can think about this also is if we rewrote this as w to the fourth plus 0w squared minus 36. What two numbers multiply to negative 36 and add up to 0? Well, the two numbers that multiply to negative 36 and add up to 0, well, positive 6 and negative 6. Examining both of these factors, they're not perfect squares. W squared is a perfect square, but negative 6 and positive 6 are not perfect squares. So we can't factor it further, and that would be our final answer. For number 4, there's a couple kind of interesting things going on. When we're looking at the expression from the beginning, the first thing we can see is it's not in standard form. So to do any type of factoring, we always need to rewrite an expression from the highest degree, or the highest exponent, to the lowest. Once we do that, we'll then ask ourselves our first question. Is there a GCF? In this case, the a term is not 1, so we're going to have to take out that negative sign and the GCF. So the GCF here will be negative x. All the terms share an x, and again, we always want to take out the negative sign if it's in the front. After we take out negative x, well, what's left behind is x squared. Negative 1x to the third divided by negative x is x to the squared. Negative x squared, taking away negative x, leaves behind positive x, and positive 6x divided by negative x gives us just minus 6. After that, we can ask ourselves whether we're able to factor this trinomial further. X squared plus 6x plus x minus 6. We're looking for two numbers that multiply to negative 6 and add to positive 1. That would be x plus 3 and x minus 2. Again, there's a negative x in the front because that was the greatest common factor. For number 5, we're back to factoring when the a term is 1. Two numbers that multiply to negative 24 and add to negative 10. We're negative 12 and positive 2. So the two factors were x minus 12 and x plus 2. For question number 6, we see the a term is not 1. So we'll first need to ask ourselves, is there a GCF? In this case, yes, there is. 3 is a GCF of all of these. So if we take out that GCF, we'll be left with x squared plus 5x minus 14. We'll then need to try to factor this further. Two numbers that multiply to negative 14 and add to 5 are x plus 7 and x minus 2. The greatest common factor was 3, and that needs to be part of our solution for it to be factored completely. For number 7, we notice that there are two terms. Before we do anything, we always want to ask ourselves if there's a greatest common factor. In this case, there is. And x can be factored out, leaving behind 9x squared minus 1. We'll then re-examine this binomial, and we'll notice there is no b term. Asking ourselves, is it perfect squares? Yes, 9x squared and minus 1 are both perfect squares. For 9x squared, that's 3x times 3x. For negative 1, that would be positive 1 times negative 1. So factored completely, we'll need to bring that greatest common factor down as well. The final answer would be x times 3x plus 1 times 3x minus 1.